Hi guys, just thought I'd show you a live situation. I've just left this T-con board that I was messing around with the other day. I've swapped over to a better thermocouple, although it's not a fantastic quality one, but it's better than the other one that we were trying the other day. I've just used some Captain tape, if that will focus, to hold it in place. What you can see around that IC is some chip quick that I was messing around with the other day, which I didn't show you on the video. And so I've fired this up, and what I've done, I've left the light connected so you can see when the heater's actually coming on and off. And what I did from cold, I set the set value to, I think, 50, and that fired up, and we got about 20 or 30 degrees of overshoot, which you probably would expect from stone cold. But now what I did is I let the temperature go up to around the 70 degree region, and then I just used the set button and increased the set value up to 67. And now you can see it's controlling it, I think, between with an accuracy of about 5 or 6 degrees above the set value. So it will get up to about 73, and then it will start dropping down to the set value of 67, and you'll see that light come on again in a minute, and that will turn the heater back on. So yeah, any second now it will trigger back on again. It seems to only drop about 1 degree lower than the set value, so you know, it's pretty good. I'm surprised it's as accurate as it is. So that's going to fire up any second, and hopefully you can just see that on the lamp at the top of the picture. There we go. Yeah, lamp's on. I think it might drop down, the process value will probably drop down to about 66, and then the element will obviously have warmed up enough to impart some heat back into the board. In this case, I don't think that's going to... oh yeah, there we go, it's just dropped down to 66. I know this is flickering in the display for you guys, and now that's hopefully will start going back up again. Yeah, there we go, so it's on its way up. So what I'm going to do this time, I'm just going to increase that set value up to about 90, and actually I'm going to put it to, oops, where are we? I'm going to set it to 90 degrees, and we'll see what sort of overshoot we get when there's only a 20 degree increase to go through. Obviously the results on a larger board, which I'll try another day, are going to vary, I suspect, from what we're seeing here. I'm hoping this won't overshoot too badly, but the thing is, of course, once you've done some experimenting with this on various different boards, you'll be able to predict the overshoot and you know, dial it in accordingly. And once you're at an overshoot level that you're happy with, you can just increase the set value, and it will hopefully hover around that 5 or 6 degree margin. So we'll see. Let's see what happens now. That's gone out at 90. I reckon this is going to go overshoot by a little bit. Let's see. To 97, 98, 99, that's 100 degrees. So I think that's hovering around 100 now, 101. Still a little bit of smoke Now that's there's a 10 degree overshoot now. So if I actually now quickly set this up to 100, I'm hoping the overshoot will not be as much. And if it's like the lower temperature, hopefully it will hover around the 5 to 6 degree margin above. Yeah, so it's quite interesting. Sorry if this is boring anybody, but I just thought I'd show this live. This is the first time I've done it. I should have filmed it from when I first powered this up, but I wasn't sure what the smoke situation would be from the element. So climbing again, I think now. Again, as I said on the other video, I think there is an overshoot learning process, which I will have to read up on. I don't know whether we can utilise that function or not. But I would be quite happy with a 5 or 6 degree margin of error above here, because as long as you know that, as long as that's repeatable, then you know what to set the meter to, the set value to. So if this only goes up by 5 or 6, 104, 105, 106, I'll be quite pleased with that. That's dropping back down again, so that's only, what was that, 4 degrees above the set value. Yeah, we do have a bit of smoke coming off now. I might have to open the door a bit. So let's fire the element back up again, around the 100 degrees. Okay, interestingly it's dropped by 2 this time, before the element started to reduce its heat. Okay, so 3. I don't suppose it's helped that I've opened the door actually. That might well be in fact I'm pretty certain that is exactly what's caused that, because it's pretty cold out there and the wind's blowing the air straight into to where I'm sat. Climbing again now. Don't know whether you'll be able to see the smoke on there. Probably not. Yeah, so that's off at 100. Let's just watch the overshoot. So 5 degrees already, 4, that's 5 again. I think this just is the air that's cold in the workshop. I've just disturbed it all by opening the workshop door. You can probably hear the rain again on the roof. I think that's settling at 105, so I suspect that will drop down now. So yeah, I'm okay. I'm quite happy with a 5 degree margin of error there. Let's say we wanted just to preheat this board at 120, say. I'd be quite happy taking my time in just soaking this at 50 and then maybe 80 and 100 and then up to 120. I've got no issues with that. What I don't want is this full power soak and get it right up to the maximum temperature in a minute idea. I'm not keen on that. As I mentioned, I think on the other video, I have seen a Chinese BGA Re-work station that does have the PC410 as the lower heater control, as well as using it for the upper heater control. So of course you can set the ramp values and just gently warm the board up to whatever temperatures you want to deal with. I think we achieved on this same board temperatures of around 200 degrees on maximum the other day. So I think it was really only suitable for the smaller boards. I think the next one I'll try in this will be a larger inverter board. See what happens with the overshoot and things like that on the larger boards. So we're up to 116. I'm assuming that you can actually see this. I know it's flickering. Right, so we're at 120, that's the set value. I'm guessing at least 5 or 6 degree overshoot perhaps. At this stage, of course, the chip quick that I've put around that IC is liquid. Okay, so what have we got here? Well, that was a 2 degree overshoot, and now down to the set value again. So I'm wondering if there's getting, as the heat gets higher, whether the overshoot will be less of an issue as there's more heat in the board and the surrounding jig. Strangely, we're losing some heat there now at the other end. Yeah, so maybe we've got some undershoot now rather than overshoot at the higher temperatures. Again, 4 degrees. I haven't got an issue with that particularly. Of course, we're going to have some accuracy issues with the thermocouple that's used, how well it's in contact with the board, the accuracy of the actual Rex C100 also. I suppose I should check this with the fluke. I'm getting temperatures of around the 137 region around the IC. Which is more accurate, the Fluke 62 or the thermocouple? I'm not so sure. I've just noticed the thermocouple isn't in fantastic contact with the board because it's just resting on there. Yeah, that's my fault. The thermocouple was not, although I stuck it down, the tape's come loose and it's just it's not making good contact. So yeah, that's my fault. I'm trying to try and rest it in the chip quick. Yeah, so you can see that's higher than it should have been. But the point here was just to prove the what overshoot and undershoot we were getting. So yeah, despite the fact the thermocouple was in the air, it was fairly closely controlled, I think. Yeah, I've just taken that off now, so we'll just turn the element off. Okay, well, apart from my stupid positioning of the thermocouple, I'll just show you how that's actually off of my other jig, and it sits on a rod. Normally it's bent over more, and it sits on a pole and just rests on the board like that. So I've just pulled that off of the other jig just to try it on here. So yeah, I think that's a fairly good result. I don't mind 4 or 5 degrees of over or undershoot. I don't think that's that critical. Probably you can see the chip quick is, I'm assuming, still liquid. Yeah. If I'd actually put this on correctly the other day and I was just messing around with it, it would have been possible to lift this IC off, but I really needed to apply some flux and some normal solder first, just before applying the chip quick. Anyway, so yeah, I'm quite happy with that. I'll test it on a larger board again in a day or two, and see where we go from there. So sorry, that's been a bit of a long video, but I just wanted you to see this this actually in action at long last. Catch you later.